Hello and welcome. I'm Mrs. Kidson and this is the first lesson of my GCSE preparation course. This is aimed at those in Year 10 currently who are missing out on some of their education because of the COVID lockdown and feeling a bit anxious about being prepared for Year 11. So I'm going to try and take you through some of the key topics that are really essential that we keep ticking over so we don't forget them, so that you feel more prepared when you go back to school. The first lesson is on Laws of Indices. I'm going to take you through my slides that I did in their presentation and talk through the worked examples, so hopefully it's helpful for those who missed it or didn't get a chance to log in. At any point, pause the video and have a go at the questions first before you listen to me go through them, and that will really help you see what you understand and what you need help with. Okay, have a start with question 1 and 2 on this slide. So the 1 is recapping basic indices rules. Question 2 is a slightly more challenging fractional and negative indices rules. I'm not expecting you to have remembered them perfectly, they're tricky, but have a go. Pause the video and press play when you're ready. Okay, we ready to go through them? Question 1, I'm going to go through all together. So, if we have a look at the first question, we've got to remember to treat the coefficients, so they're the numbers in front of the letters, differently to the powers, the little numbers at the top of the letters. So here, we've got to treat our 2 and 5 separately. It's a multiplication, so we just do that to the 2 and the 5. 2 times 5, 10. Then we can focus on our powers. V cubed times v to the power of 8. Hopefully some of you will have remembered when we multiply, we add powers. So we get v to the power of 11. V to the power of 3 times v to the power of 8. Next we move on to our u, and we get u to the power of 8 times u to the power of 9. We add the 8 and the 9 for multiplication. So we end up with u 17. Sorry about my stylus work here, it's quite tricky, but I'm hoping I'll get better as I go along. Question B is the division rule. So again, you can see the coefficients, the 10 and the 5 at the beginning. Treat them normally. 10 divided by 5 gives us 2. Then we've got the powers. W to the power of 14 divided by W to the power of 5. Here we subtract. 14 take away 5 is 9. So we get W to the power of 9. With Z, we've got Z to the power of 17 divided by Z to the power of 9. 17 take away 9 is 8, so we end up with Z to the power of 8. Okay? The third basic rule is a power of a power. So we've got indices in the bracket, and you can see they're all being squared. Again, start with our normal coefficient. We've got the 2, and we square it, like we're being told to just normally. 2 squared gives us 4. Then we've got j cubed all squared. That's the same as j cubed times j cubed. And when we multiply, we add powers. So we'd have a 3 and a 3, which is 6. Basically, what we're doing is j cubed twice. So we times them. Power of a power, you multiply. 3 times 2, 6. So j to the power of 6. We're going to do the same for e to the power of 10. So e to the power of 10 squared would become e to the power of 10 twice. So e to the power of 20. So power of a power, you multiply the powers. I hope that's a good recap of just the basic skills. With the next ones, question 2, I'm just going to show you the answers. I'm not going to go through these quite yet because I'm going to go through the rules in a bit more depth first. But have a look, mark the ones you've done, and if there's any you got wrong, make a little note of them and make sure you listen up really carefully when I go through those rules. So I'll just give you a few seconds to mark those ones. Okay, pause if you needed to, but I'm going to move on. So, this is our basic rules. On the left, you'll see the ones we just covered with question 1. We've got the multiplication, which shows that when you multiply, you add powers. Division, when you divide, you subtract powers. And power of a power, we multiply them. A, B, right next to each other, A times B. At the bottom here, we've got, sorry, 1 second. We have got x to the 0 equals 1. That's a reminder that anything to the power of 0 always equals 1. Even if we had a really complicated expression and that was in brackets with a power of 0, that would equal 1. Anything to the power of 0 equals 1. So it's just one we've got to remember there. Now today I'm going to be focusing on these more complex rules. We've got the negative power and the fractional power. So I'm going to take you through these one at a time. Firstly, the negative power, think of that as the 1 over. We're basically finding the reciprocal of the term. So the negative just becomes the 1 over. Always a 1 on top, unless it's got a coefficient in front of the a, and we'll talk about some of them later. But for your basic rule, 1 over, and then it's what's left. So if you can see, once I take away that negative power, I'm just left with a to the m, which is why it's 1 over a to the m. Okay, so it's just trying to remember that negative power, 1 over. Next, we've got the fractional powers, and I've got a way that I tend to do this in my class when I'm teaching it. We've got the power n over m, and I try and think of this like a flower with roots at the bottom. So we've got two parts to our fraction. We've got the m, which is the denominator, and that's the root. It's the base of the flower where the roots are, the base of the fraction right down the bottom, and it tells you what root to do. So you can see in our question that the denominator tells us the type of root, whether it's a square root, whether it's a cube root, fourth root, fifth root, and so on. Then we've got the numerator on the top of our fraction, which is like the top of the flower. And in this case, I say flower power, and that tells us the power we then do it to. So in this example, we look at the numerator of n, and it's to the power of n. So that means after you've done your root, you then, if the n was a 2, you would then square your answer. If the n was a 3, you would then cube your answer. 4, fourth root, or not fourth root, to the power of 4, your answer. Okay? Tricky, but we're going to practice some of these. But just trying to remember this infographic of the flower, with the root being the bottom number and the flower power being the top, might help you get them the right way around. Okay, let's put this into practice and have a go at a question. I'm going to do one first, then you can have a practice. So, for this first example, we've got a negative power. Do you remember the negative power meant 1 over? If I take away that negative, I'm left with 2 cubed. So that's what goes underneath our fraction. We can simplify that because we know what 2 cubed is. 2 times 2 times 2 is 8. So our answer is 1 over 8. You now have a go at 4 to the power of minus 2. All right, let's go through this one. The negative power is 1 over. And then we're left with 4 squared, which we can simplify, and we get 1 over 16. Okay, I hope that was a nice straightforward one there. It's just the negative, just remembering it's the tricky bit. Which one's which? It's the 1 over. Super, let's try a fractional one together. So this one, we've got 27 to the power of 2/3. Remember the bottom number of that fraction is my root. So that tells me I'm going to need to do a cube root of 27. Then I'm going to need to square it because that numerator, the top part of the fraction, is the power. So cube root, then square. Always do the root first as it makes it more manageable and easier to deal with. Now, if you don't know your cube roots, you've just got to guess and work it out. So you think, is it 2? 2 times 2 times 2? No, that's 8. Is it 3? 3 times 3 is 9, times 3 is 27. Yes. So if you don't know them, guess it. But the more practice you do, you'll get really familiar with them. So our answer is 3 squared, which is 9. Now it's your go. Have a try at this question. Pause it if you need longer, but I'm going to go through it in a second. Okay, let's see how we got on. The bottom number, so the denominator is the root, remember? So this time we're just doing a square root of 9. And then the flower power, the top bit, is a 3. So then we're cubing it. Square root of 9 is 3. So we've got 3 cubed, 3 times 3 times 3, which is 27. You might have noticed these are the inverse of each other. We got from 27 to 9 in the first one and from 9 to 27 in the other. That's because the fractions we used were reciprocals. They were flipped upside down, 2/3 and 3/2. Okay, let's make this slightly more challenging. What if we combine them? In this case, I've got a negative and a fractional power, possibly the trickiest and the bit that a lot of people get confused on. I would deal with the negative first. So the negative makes it 1 over, and then we've got 8 to the power of 2/3. Now let's work out what that fractional power means. That is the same as 1 over the cube root of 8, because remember the 3 is the bottom, and then squared. So if we can simplify that a little bit, we get 1 over, cube root of 8 is 2, 2 times 2 times 2, 2 squared. Then we get 1 over 4. So 1/4 is the answer to that one. You have a go at this one. Pause and have a go. Right, how did we do? Let's first deal with the negative power. So we have 1 over 16 to the power of 3/4. Now let's deal with a fractional. 1 over, and then we've got a 4th root of 16, and then all cubed at the end. So dealing with some bigger powers here. Firstly, the 4th root of 16. Remember, if it's not familiar, guess it. Is it 2? 2 times 2 times 2 is 8, times 2 again is 16. Brilliant. So it is 1 over 2, then cube it. Don't forget to do that power, really common mistake. Once you've done the root, we haven't finished. Then 2 cubed is 8. So we've got 1 over 8. Okay, let's have a go at these questions. I'm going to skip this actually. I did a bingo in the session, but don't think we need to practice all those there. I'm going to skip to a slide of some questions for you. Right, we've got 2 more examples, and this is the harder it's going to get in this session. This one here is the fractional bases. Now you'll notice it's a negative power, like we've been dealing with, but a fractional base. So not the power is fractional, it's just the base. So don't get confused, we're not using the flower power root, it's just the base is fractional. This negative means 1 over, remember, but we're not going to do 1 over 2 over 5 and then cube it. Gets messy, we don't want fractions of fractions. But here it's worth understanding what the 1 over actually means. The over in a fraction means divide. So we've really got 1 divided by 2/5 cubed. And if I'm dividing, that's dividing our fractions. We can remember our fractions division rule. Keep, change, flip, or you might learn it slightly differently. But we keep the first term, change the second to a multiply, flip the fraction at the end. So we have 5 over 2 now cubed. So if we do 1 over, or 1 divided, it's basically just the same as flipping that fraction. So if it's already a fraction, we flip it rather than doing 1 over. So now we've just got to work out 5 over 2 cubed. And you just cube each part. Cube the numerator. 5 times 5 is 25, times 5 is 125. And cube the denominator. 2 times 2 times 2 is 8. So that is our answer. So you don't have to do all of this work every time. It's just where I'm showing you that it's the same. Dividing is the same as flipping and making that reciprocal. Have a go at your question and we'll see how you get on. And then I'll explain it one more time. Right, let's have a look at this one. So the negative power, because it's already a fraction, it just means we flip it, turn it into its reciprocal, upside down. It's still to the power of 2, because we've just used the negative power at the moment. So we've got 7 over 3 squared. Square the 7 and we get 49. Square the 3 and we get 9. Final answer. It's a top-heavy fraction, and read the question carefully because it might say leave it as a mixed number. So just read the question carefully there, but this is the skill I'm assessing at the moment. All right. One more with fractional bases. What if we've got a fractional basis and a fractional power? So this one is actually easier. We don't need to worry about flipping it. That was the reciprocal, the minus power. Here we just do the 2/3 to the top and the bottom separately. So we're doing the cube root, because my root is that 3, of 1/8, and then we're squaring it because my power is the 2. Cube root of 1/8. Cube root of 1 is just 1. 1 times 1 times 1 is still 1. And then I'm going to have to square it. Cube root of 8 is 2. Then I'm going to have to square it. So just remember we've still got to square them. 1 squared is still 1. 2 squared becomes 4. So my answer to this one is 1/4. So it's exactly the same as when we did the fractional indices before. You just do it to the top of the fraction and to the bottom of the fraction. You try this one for me. Right, let's go through it together. So we've got to square root 4/9 and then cube it, because remember the 2 was my denominator this time, the base of the fraction, and the 3 was the flower power at the top. So the square root of 4/9 is going to be 2/3, because the square root of 4 is 2, the square root of 9 is 3. Don't forget we've still got to cube it. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Final answer. Okay, pause it and rewind, listen to my explanation again if you still need to, but hopefully that's gone in. Let's try some practice questions now. You've got a mixture here. You don't need to try them all, although if you've got time, it'll be great practice, but maybe focus on some that you think look a little bit trickier. Some that I will talk through in the end are these ones, because these are the ones with coefficients. Now at the beginning I said it's slightly different. So maybe have a go at the others first. But if you're feeling confident, try the ones I've starred. Off you go. Right, pause it if you're still working, because I'm going to reveal the answers. Okay, there you go. Mark your work. And pause me if you need some time to do that. But I'm just going to talk through some of the trickier ones. Firstly, let's mention this bit up here. The answer, the square root of 121, because that 2's at the bottom, it means a root of 121. So the answer is 11. In front of it, we've got plus minus, because hopefully you've remembered that the square root of something could also be negative. Because if you think about minus 11 times minus 11, we would still get a positive 121. So it just means the answer could have been negative 11 or it could have been positive 11. We don't always have to write the plus minus when we're square rooting, but if your question has asked for 2 answers, that's where your second one's coming from, minus 11 and positive 11. So just keep an eye out for it. Secondly, I'm going to go through the ones I starred because they're slightly more challenging. I'm going to go through this on the next page, so I've got a bit more space. And we're first going to look at 3x to the power of minus 4. So we've got 3x to the power of minus 4. Now, if you think about BIDMAS, which bit of that expression is the power relating to? Is that minus 4 on just the x or the 3 and the x? It's actually just on the x. Because of our BIDMAS, we've got our indices, which is where our power is, before our multiplication, which is the 3 times the x. So our indices comes first. So that means the x to the minus 4 is its own little term there, and we've got to do that first. So this bit becomes 1 over x to the power of 4. Now previously, when we were dealing with numbers, we could simplify that. This is a letter. We can't do anything with x to the power of 4, so we're done. We leave it like that. But we've still got this 3. And this 3 was right next to the x, so it means 3 times x to the minus 4, or 3 times 1 over x to the power of 4. 3 lots of 1 over x to the power of 4 is just 3 over x to the power of 4. That's because we could write an imaginary 1 underneath this and make it into a fraction, and then just do your fraction rules. 3 times 1, 1 times x to the power of 4. Okay, but sometimes it's worth remembering that if there's a coefficient in front of the letter and power, then it goes on top. So rather than 1 over, that's become 3 over x to the power of 4. Okay, let's look back at one of the other questions we had on that slide. We've got similar in the next question below it, 2x to the power of minus 3. But can you tell what's different there? We've got the brackets. So this time, the whole expression is to that power. So 2x to the power of minus 3. Let's have a go here. 2x all to the power of minus 3. So this time we start with our power, but it relates to the whole expression. So we've got 1 over all of this, 2x to the power of 3. Then we can simplify a bit. 1 over, and our normal coefficient, the 2, we treat normally 2 cubed is 8. X cubed is x cubed, which is why we end up with 1 over 8x cubed. Okay. I'm not going to go through the other two because they're similar. It's the same process. It's just remembering that you have to do the power on just the letter if there's no brackets, but if there are brackets, it's the whole term, which is to the power of. Okay, fab. Let's try some slightly more challenging questions here. So if you need further practice, for example, you still found those ones quite difficult, or you just want to practice some of those skills again, try this first activity, the pink and blue one. If you, however, found it okay and you're ready to move forwards, try the challenge questions. There's 2 of them there. With the first activity, the pink and blue one, you've basically got to match terms from the pink column and the blue column. So for example, question 1 there, the square root of x, you need to work out how else that could be written. So how could we write that with a power? And then try and find that in the blue column and write down whatever letter 1 goes with, and so on for the rest of them. Okay, pause it and have a go. Right, should we look at some answers? Make sure you've paused if you're not quite ready. Okay, there we go. Solutions on the left for the pink and blue ones. So that's what number and what letters go together. I'm not going to go through all of those, I'm afraid. If you've got any questions, do comment and I'll try and get back to you. The challenge question was slightly trickier. I hope that explanation makes sense. I'll just walk through it slightly. So on the top, I've rewritten out 9 to the power of 9 is just 9 times 9 times 9, 9 times. And 10 to the 9 is 9 tens written out. Then part B is 10 nines and 10 tens. So the difference is we've got an extra 9 on the top and an extra 9 on the bottom. So that means to get from A to B, we've multiplied by 9 on the top of our fraction and 10 on the bottom. So we've really multiplied by 9 tenths. Now if you times something by 9 tenths, it becomes smaller because you're basically finding 9 tenths of the item. You're splitting into tenths and you're only wanting 9 of them, not the full 10, which would have been our first answer. So that's how you can see that A is the larger quantity. With the second challenge question, this is a tricky one and it's involving changing the bases. So I'll just go through the first one, 8 to the power of a half. Now you can see we're trying to compare 8, 4, 32 and 2. Hopefully you spotted they're all powers of 2. 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. So we've got to make them all base 2. In the first one, we've changed 8 to 2 cubed, because I could write it that way. and I've put it in brackets, still with the half as a power above it. So 8 to the power of a half is the same as 2 cubed to the power of a half. Now we've got our basic power of a power rule. Remember we multiplied them? So 3 times a half is 3 over 2. So that's the same as 2 to the power of 3 over 2. I'm going to leave that there for now. We then try the 4, we make that 2 squared instead and do the same thing. The 32 we make into 2 to the power of 5 and simplify it the same way. Now we've got the 2 to the power of 5 over 6 at the end. We don't need to change, it's already base 2. But we've got denominators of 6, 3 and 2 there, which are hard to compare. So we're going to make them a common denominator of 6. So just ignore the fact that they're indices. The same rules apply as normal fractions. Change them so they've all got a common denominator of power of 6. And then we've got 2 to the 9 over 6, 2 to the 12 over 6, 2 to the 10 over 6, and 2 to the 5 over 6. So now we can put them in ascending order. And remember, with any of these style questions, always write the original numbers you were given as your answer. So you'll see my answer on the right there. It starts with 2 to the power of 5 over 6, then it's 8 to the power of a half, I've written the original term, 32 to the power of a third, and 4 to the power of 2/3. Okay. Please don't worry about those challenge questions if they've gone over your head a bit. That's really top end there, and it can get quite tricky. It's definitely hard to explain just over a video like this. But I hope you are happy with the basics. If not, go back, listen to some of the problems again and try them yourself. Right, all that I wanted to say was about the next session. So the next session, ignore that previous slide, will be on YouTube on Wednesday the 13th. So that is tomorrow, if you're watching this on Tuesday, at 5 p.m. And the link is there. The resources from all of my lessons can be downloaded from my website, mrsk'slightbulbmoments.wordpress.com. You'll be able to download the PowerPoint presentation beforehand so you can write straight into it, and that means you can also see all the key points while you're going through, even if I click away onto a different slide. And you can find further practice questions as well there on Corbett Maths. I've also linked to that from my website. If you've got any feedback you'd like to give me, there's a link to a poll everywhere. Poll, if you could add anything into that, that would be great. But make sure you are following my Facebook page for live updates, because that's where, if there's any changes, I'll be putting them up, and any reminders I'll be setting. If you subscribe to my channel on YouTube, you can also set an alert, a little reminder for when the next lesson's coming up, so you don't miss it. All right, that's all for now. See you Wednesday when we're going to be doing surds.